And we will start the PowerPoint. So you can see there, finally, we are at Unit 2, all right? And we are dealing now with calculations involving chemicals. So what have we done so far? Well, if you want to really kind of summarize it down, we learned about the atoms and the charges they can have. We learned how to put those atoms and ions together to cross over their charges to get the formulas. We've just learned how to put chemicals together and then know how to determine what type of reaction they undergo: synthesis, decomposition, single displacement, double displacement, combustion, right? And so we're ready now to look at the mathematics of the chemical reactions, all right? So we're going to look at how we measure atoms and how we measure molecules and how we deal with them in a chemical reaction so that we can do a chemical calculation. So this is just the beginnings. And so you can write down Unit 2, Chemical Calculations. And again, I don't know where everyone is at. Am I going ahead? Nobody's saying stop? Okay. And we're going to first deal with something called the atomic mass. All right. And we are going to be using our periodic tables to find the atomic masses. You don't need to write those pictures down off to the side. We will be looking up some atomic masses here in a moment. We'll be looking up so many atomic masses that when we get going that you're going to start to even memorize some of these numbers. So the atomic mass is the mass of one atom of a particular substance. And that atomic mass is found on our periodic table. So please get your periodic table out. And if you don't have one, again, you can come up and grab one here. And you'll notice those pictures on the slide are much like the periodic table that I have here. But I want you to be able to find the atomic mass numbers. So let's look up zinc, Zn, and you can write that down. And if you look up zinc, I see here 65.39. And could you please look up zinc on yours and find where your mass number is? I believe it is, where is it? At the top right-hand corner. And my zinc says 59.39. And what does your zinc say? 65.409. That's exciting. They're a little different. It doesn't matter that they're a little different. It means that someone who built this table took their numbers from a source that maybe did some experiments to figure out the mass, and these people did slightly different experiments. It doesn't matter if they're slightly different. We're going to write down our masses to 1 decimal. So mine would round, 65.39, would round up to 65.4, and yours would stay 65.4, right? So for zinc, and this is the way I like to write the numbers. I like to use a little arrow system. 60, and I've been talking so much, 65.4, all right? Do you see how to find that on your table? Nice. Now we need a unit to go with this. Now atoms are not very heavy. So there is a specialized unit that we use that is a really tiny small mass. And the U is the unit that we use. It's a little tiny mass unit. That U stands for atomic mass unit. All right? And I'm going to write a number down here in a moment, but you don't have to write this number down. I'm going to tell you how small that mass really is. If I had one atomic mass unit, its mass is 1.66 times 10 to the negative 24 grams. Don't write that number down. I simply wrote it down to express to you how tiny this atomic mass unit is. So one zinc atom is 65.4 of these little tiny mass units. All right? I did want you to write down atomic mass unit. Just don't write down the number. Have we done that? Excellent. So the little u stands for atomic mass unit, and it is a very tiny mass number. All right. And I've got some words on here. Yeah, that's great. And I wrote that down for you. So let's find some others. Just put EG, and don't write down find the atomic mass and round to 1 decimal. We're going to do that, obviously. But let's just do some examples here. And I'm going to bring them in. And the notation I like to use is this arrow notation, because when we start to look at formula, we're going to have an arrow for each element. So this arrow notation is interesting. There's no official way to do this, but that's the way my chemistry teacher taught me, and I suspect that's the way his chemistry teacher taught him. And so it's interesting, you always kind of do what your teacher taught you. So then maybe someday when you become a chemistry teacher, this is the way you'll teach your kids. That'd be fun. Anyway, hydrogen to 1 decimal place. What do we have for a number? Again, we're rounding to 1 decimal, so we look at the second decimal to decide how we're rounding. Yep. And let's write that, yeah, 1.0, 1.0. The unit? U. Now, that 0 is important. It means that someone has gone to great lengths to measure this mass so accurately that on my table they've got 1, 2, 3, 4, 5 decimals. And so we know to the first decimal that this is exactly 1.0. So the 0 is important. It's so important that we have a name for this digit. We call these digits that we're counting significant digits. So this has 2 significant digits. And that's going to become important when we do calculations. It means that we've measured that number really accurately, so we know it not just to the number 1, but exactly to 1.0. And as I've been talking along, some of you have already been starting to check out some other numbers. Do we have gold rounded to 1 decimal place? Conrad, are you going to give me something? What do you got?
Gold, I got 197.0.
I'm looking at the wrong number. 197.0. That's correct. That's good. 197.0 U. Notice again the point 0. It means that some chemist has gone to great lengths to know this to that many decimal places. And I'm going to do this just one more time. This number has 4 significant digits. 1, 2, 3, 4. It means we know the number so well that we know with great confidence all 4 of those numbers. All right? N, the atomic mass for nitrogen. Yep. 14.0 U. Excellent. 3 significant digits on that one. We know it so well, we know it to 3. We actually could know it to more because the periodic table tells us more, but we're only going to keep the 1 decimal. And PB, what do we have for PB? Yeah, Conrad? 207.2 atomic mass units, and 207.2. Mine actually stops right there. Does yours have more detail, or what do you got? Notice the digit after the 9 is a 6. That's going to tell us to round up that 9 to a 10. That gives us a 0 in that decimal spot and changes the 6 to a 7. All right? So what was that? 196.9, I believe it's a 6. Yep. Did you get it taken care of? John, did you get that? So this one, right, turns this into a 10, right? Yeah. And if this becomes a 10, then this becomes, the 10 of the 10 goes into that, and the 0 of the 10 goes into that. Right. It doesn't, so there's some of ours that has it cut off. Yeah, was it cut off on that?
Mine's on there, just it's not bold.
Yeah, we've got to fix our table. Yeah, I've got to take a look at some of those. Did Gold have some of those numbers cut off at the beginning or the end? The one is. We've got to fix that. That's an error on my periodic table. It cuts it off on the left. So we got to fix some of those. So what you can do is, if you find that there's a number that you can't see, just write it on your table, maybe with a pencil or a pen. Just kind of fix it. All right? There's a couple that we're going to have to fix. And I apologize for that. That's me making the font too big that it cut off some of the number. Okay. I'm going to let you write this whole thing, and then we'll discuss it in a moment. Yeah, fluorine is one that's also cut off on your table. Fluorine should be 18.99, and in fluorine, the 1 and the 8 is cut off. Like the whole 18 is gone. That's the one I noticed. Gold, there it is there. Gold has the 1 cut off, right? So fluorine should be 18.99. And there was one other. Oh, aluminum is also cut off because there's too many decimals and it pushes it over. But we'll get those fixed as we go. We'll get those fixed up as we go. I may have to change it on my original format and then print off some new ones for when you do tests and that, so that we can find the numbers. Like cesium is also cut off. Not that we use cesium a lot, but it's cut off. Okay, so we've currently just dealt with atoms. What we want to talk about now is the formula mass, which is the mass of one formula. Now we're introducing a new term to you right here, and this term is entity. An entity is really a big fancy way of saying things, different types of things. Yeah, I'm gonna complete the table. The table is important on this. This is going to tell you what an entity is, and then we're going to be using entities on Wednesday after we're done the review and the test. We'll be calculating these entities. Yep. Do I have a ruler? Yes. You don't have to actually make a table, but I do have a ruler if the existence of a table causes you stress without straight lines. No problem. So the formula mass, essentially it's the mass of the formula of whatever we're talking about. Now these entities are the whatever we're talking about. Sometimes we talk about ionic substances. Sometimes we talk about molecules. Sometimes we talk about atoms. And sometimes we talk about ions. And those are essentially what we consider entities in the chemistry world. They're the tiny little things that we deal with as chemists. The little groups of atoms that can group together in some way. So an entity is the smallest part of a substance that is given by its chemical formula. So if I have an element just by itself that isn't one of these Hofbrinkel gases, then the smallest piece of an element is an atom. Now, I don't like the red, but that's okay. We'll keep the red for this note. So if I'm talking about a cobalt entity, its smallest piece is an atom. Cobalt atoms are the smallest pieces that make up cobalt. An example, well, I might as well use cobalt. CO. Or anything else other than these guys in red, not including the noble gases. The noble gases are elements as well. Maybe I'll put one of those in there. Ar, argon, atoms, or any of the noble gases. If I have an ionic compound, the smallest piece of an ionic compound we called a formula unit. Right? Remember, we had a funny name for it. It's the smallest piece that is the formula. An example of a formula unit for ionic compound, I'll pick anything that has a metal and a non-metal. Let's say magnesium chloride. You know, metal, non-metal, cross it over. So the entity that represents an ionic compound is called a formula unit. But in the end, we're going to just call them entities. We're going to lump them all together and describe them as entities, the smallest pieces of whatever it can exist. For a molecular element, it's called a molecule, and that's true for a molecular compound as well. We call these molecules. Remember, they're the things that are bonded together. Things that are bonded together with single and double and triple bonds. A molecular element would be H2 or O2 or F2. That's that Hofbrinkel scenario, etc. Those gases that we talked about. These guys here, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, hydrogen. A molecular compound, its example, will go with good old H2O. Water is an example of a molecule. So again, these are the entities. The entity of just an ion is an ion, right? So if I've got the smallest charged part of a piece of material, it's just called an ion. And some examples of some ions, well, I'll put Cl minus. A chloride ion, but it could be SO4 minus 2, a sulfate ion. So any of those charged things that we deal with. What I'm saying to you is we simply can call these things now entities, the smallest piece of what that material is. So what's the formula mass? It's the mass in U of an entity of one of these guys. It's really easy to calculate. We just add up all of the atoms. So these are the entities. Let's do some formula masses. Formula mass, oh, formula unit mass. Just put EG. Just put EG. Just put EG below this. Don't write the table. Don't get the rulers out. Don't do any of that stuff. Just write EG. EG, I'm switching to black, and in the part of your page, put NaCl, and I'm going to make it nice and big. Just write down NaCl. Don't write any of that stuff down. Just put Eg. This is overkill. Just put Eg and put NaCl. Using the same arrow notation. What's the mass of a chlorine to 1 decimal? Be careful with this one, it's a trick. 35.5. Yeah, very good, 35.5. 35.5, what's that? Why is it a trick? It's the 0.5, normally it's a 0.0, that messes everyone up, but that's good. I'm going to do another arrow notation. What's the mass of a sodium to 1 decimal? Conrad?
23.0.
Yep, nice. 23.0. If I write my arrows like this, I can put a line underneath that represents add these up, like an addition, like adding. Now get your calculators out, right? Which Bethany doesn't have. She's got oh, she does. Excellent, good job. She's hiding under the periodic table. That's nice. And add those two up. And this is where you want to play along, even though this is really quite. Have you already done it? Oh, okay, nice. What do you got? What is that? 58.5. 58.5 U, atomic mass units. Just put the unit on the last one. That's all that matters. Let's look at this. FeCl3. Hold on. If you write it with the arrow notation, the calculation builds itself. The mass of a chlorine, 35.5, and just put times 3 on the back end of it. So what we're doing with this arrow notation is getting you to build the calculation. 35.5 is the mass of 1. There's 3 of them times 3. Fe, what is the mass of an Fe to 1 decimal? Yep. 55.8. 55.8. Now, don't do anything fancy. No need to do the multiplications first. Your calculators will do this for you. All you have to press 35.5 times, right? That's the button with the X, right? We know how to find that one. Okay. 3, then plus, then 55.8, then equals. All you got to do is type it in the way it looks, and you'll get the number. What do you got? 162. Was that? Did you say 162.3 U? Supporters on that? Do we like it? Okay. All right. One more example, and then I'm done my lesson for today. Today was just formula unit. That's pretty straightforward, I think, right? We're pretty good. And then there is a sheet with some practice stuff on it, and then you'll be able to work on that. So last one here. And I'm going to write this out a little larger. NH4 brackets 2SO4. And you can see here, I'm showing you what to do if you've got a brackets, right? How to deal with it. Different textbooks do it differently. I like the arrow notation because it turns it into a nice addition for you. And hopefully you've already started looking for some numbers. That would be awesome, because that's what we're going to eventually have to do. This is the type of thing we use a lot of when we do calculations. So, excellent. You're all looking down, which is good. You're looking at your pages. I'm going to start writing some numbers. Don't look up at me yet. You can check later on. 32.1 for S? Yeah. 32.1? 32.1. Now, this brings us to here. How many H atoms are there? Conrad?
2.
Nope.
8.
8. 2 times 4. Sorry, H. No, H. N, there's 2. You're correct. We have to multiply it through. Did I say? I don't think I said it. But anyway, it doesn't matter. We have to multiply it through. So 2 times 4 is 8. So that's 1.0 times 8. 2 for the n's, that's 14.0 times 2. And like I said, your calculator will just do this. All you got to do is 16.0 times 4 plus 32.1 plus 1 times 8, or you could have just put 8, plus 14.0 times 2 equals, and the calculator will take care of the work for you. And I will take a number, yep.
132.1.
132.1, 132.1U. We like it? Supporters? All right. That's what Formula Mass is on Google Classroom. There's a practice sheet. There's answers there too. You've got the rest of the class. Now that class is over in another half an hour because we're done 15 minutes early. But you can work on some of these formula units, or you can start looking at the test review. I think I've already put it up on Google Classroom. So let me just stop my video here, and then I can address any questions if anybody